Let's continue our discussion by looking at regular expressions. Regular expressions, as we said before, are strings that signify patterns of characters in other strings, okay? Sometimes you'll hear me just refer to these as regexes, okay? These are patterns like email addresses look like something at something dot something, right? But the question is, how would we actually express that to the computer? All stringr core functions that we talked about before, str, detect, replace, all that kind of thing, they all work with regular expression patterns. So not just the E that we were looking at before. The E was just kind of a placeholder, and it itself was technically a regular expression, but it's a very basic one, okay? So we're going to look at this as a much broader collection of character strings that we can pass in for detecting, matching, replacing, that kind of thing, okay? Now, one of the things that you should try to get into the habit of is thinking of regular expressions themselves almost as a kind of code, almost as a kind of programming language for a different kind of interpreter that isn't R but is a regular expression engine, okay? There's a great reference for this called Mastering Regular Expressions. That's a live link. You can click on that, and it's kind of a full book-length treatment that's very practical for regular expressions. So if you're doing more of that, I would encourage you to look into it, okay? Now, I wanted you to think about this sentence here because it will be important for us understanding how regular expressions are going to work broadly, okay? So the sentence is Bill bested Bob. Technically speaking, in the R language, that's a character vector of length 1. So we would actually say that it is a string, okay? And we know that str extract all is going to pull out all of the instances of B, okay? That lowercase b character there. And we get a list back, right? It's a list of length 1 because it's a character vector of length 1. And that first element is a character vector of length 2, which are the matches that were extracted from that sentence. And it pulls out the first b, meaning the first lowercase b of bested, and the last lowercase b of Bob, okay? Now, there's a question which is kind of why did it not pull out the big B's? And that's again because it's case sensitive. It cares about the difference between an uppercase and a lowercase character. So the B in that str extract all says match the literal character B, but not an uppercase character B, okay? Regex engines are typically case sensitive like this. So this is the standard behavior of regular expression engines. And this is why they're doing different things for an uppercase B and a lowercase b, okay? In writing, sometimes it's actually challenging to communicate the regular expression when I'm writing distinct from the rest of the surrounding text. So like above, you see me writing it in quotes, quote B, quote, okay? And so on. Now, this is not as big of a deal as it was in the past because we have different ways to format text on a page. Nevertheless, occasionally, if you're looking online, you may see regular expressions fenced in forward slashes. That's a common way to actually see this. So the /b/, the regular expression part of that is just the B. It doesn't include the forward slashes. But people will show those forward slashes to say, hey, it's stuff between here, okay? Sometimes we'll colorize it. Sometimes we'll surround it by quotes and so on. Okay, now consider this kind of nonsense phrase. Hit, hat, hot, him, hilt, okay? str extract all h dot t. And look at what comes out of this. So you can see just by the highlighting that it actually selected, that it matched hit, hat, and hot, and then it extracted those, right? Notice again, that's a character vector of length 1. So it's pulling out those entries as a character vector of length 3, but it's pulling those out actually of that same string, okay? It had 3 matches in that string. Now, there's a question there, which is, why did it not match him or hilt? Or maybe just, why did it match those 3? Why didn't it just match h dot t? And that's because in regular expression speak, the dot is a meta character that communicates match any character. So sometimes people will call these wild cards, okay? Or wild characters. They can match any character, okay? So dot means any character, but only one of them, okay? In regexes, a meta character, so this is a kind of definition. What is a meta character? A meta character is a character that is interpreted in a non-literal way. So when you see the symbol dot or period, you don't think it's the end of a sentence or something like that. You don't think it's supposed to match a dot, which is kind of the more important or relevant literal sense here, that it means something else, and the something else is match any character, okay? There are lots of meta characters that are universally regarded as meta characters across regular expression engines. I didn't mention this before, but it's certainly worth noting that the regular expressions that we're learning in this discussion work not just for stringr and R, but also works generally speaking for pretty much any regular expression engine that you're going to encounter. So if you're working with strings in Python, same regular expressions. If you're working with strings in Julia, same regular expressions. Okay, all of the regular expressions are going to be almost identical across the board. Okay. So metacharacters, these are going to be in all regular expression engines, and they always mean the same thing. And there's a listing below, dot, times, plus, and so on, that all communicate regular expressions. They communicate something other than what they look like. Okay, so we'll have to learn the meanings of these. Fortunately, they're not actually very challenging to learn. Like most of them have to do with quantifiers, and so we'll see this kind of in a table. But otherwise, it's not simple, but you do have to actually memorize what they are. Okay. Now, the idea of a meta character raises another issue, which is this. If the period is a meta character and it's being used to play the role of like a wildcard, like match any character, then the question is, well, what if what you want to communicate is you want to match literally a period, right? You want to match the literal sense of period, not the kind of meta or non-literal sense, okay? For that, we need something to signify that we want to change the normal meaning of the character, okay? And to do this, we need to put a backslash in front of it. This is going to play the role of doing something called escaping. So it's going to escape the character that comes immediately after it, and in this case, it's going to be a period, okay? The way that I like to think about escaping is like your keyboard in front of you, okay? On your keyboard in front of you, you have kind of every letter of the Roman alphabet, and they're all listed off in their uppercase demarcations, okay? But when you actually push one of those buttons and you're in some kind of text editor, it gives you the lowercase version, right? And if you want the uppercase version, you actually need to push a different button on your computer, on your keyboard. You need to push the shift button. And when you have the shift button held down, all of those other buttons have kind of a different meaning, don't they? They still mean, A is still A, but now it goes from a lowercase to an uppercase, right? If you go to D, lowercase, uppercase, and so on and so forth, right? Whenever you push down the shift button, all of the other buttons kind of like change their meaning, okay? Now, usually the sense in which they change their meaning is not a big sense, lowercase to uppercase, but in some cases it could be, okay? And in this setting, when you're dealing with regular expressions, you should think that every character that you can type has a meaning that's associated with it, which is kind of like its default meaning, right? So like an F is an F, okay? An M is an M, okay? But we know that a period, its kind of default meaning is actually not the literal meaning of period. We know that it's actually a wildcard, okay? So this notion of escaping is going to be kind of like like pushing the shift button, okay, on your computer. It's going to change the meaning of the character that immediately follows it, okay? And the way that you should think about this is it's going to toggle whether it's going to be understood in the literal sense or the meta sense, okay? So the default for the period is the meta sense, okay? That it is understood to be a wildcard. But if you put a slash in front of it, a backslash, then it's understood in the literal sense, right? It toggles literalness, okay? That's just a me word making it up, okay? Nobody else uses this term, but I think it's helpful to think about it like that, okay? So meta characters, when you escape them, when you put a slash in front of them, will become literal, and literal characters will generally become meta on you when you put a slash in front of them, and then you have to understand what their meaning is, okay? Like what's the meta meaning of /n or /r or something like that? Like you just have to learn what those things are. Now, in R only, I said that regular expression engines generally work in kind of any language or any framework that you're in. It's going to be essentially the same regular expression language. But in R only, when you are typing in backslashes to escape a meta character, this is a kind of an oddity of the language. You won't use one slash, you'll use two, okay? This is just how it works. So, and if it ever gets confusing to you, if you type in 2 and it doesn't work, type in 1, okay? So some characters are like that, but the vast majority of the situation is you're going to be putting in 2 slashes for that 1 slash. So the 1 slash is generally for regular expressions. R is weird in this sense, and you'll put in 2 slashes, okay? Now, let's get an example. So here I have 123 space 1.3, str extract 1.3, and it extracts 123, okay? Take a minute to think about why that's the case. Okay, so the reason why that's happening is that the 2 is being matched by the period because the period is playing the role of wildcard, right? If you wanted to match it literally, now you need to escape it, right? Go from meta to literal, and now it's going to match only the period 3, and it matches the 1 period 3, okay? If you understood this, you understand kind of like the basic concept of meta-ness and how the period works and so on, okay? This is generally how it works. Now, there's another way to effectuate this particular situation where you want to match a single character in that single character's period. And that is to bracket it with hard braces. And that is because hard braces themselves are meta. You could go back to the previous one, you would see, oh, hard braces are meta characters. They're understood in a non-literal way. So this regular expression that we're looking at right here doesn't say match a 1 followed by an opening hard brace followed by a period followed by a closing hard brace followed by a 3. It's saying match a 1 followed by a character that is a period followed by a 3, okay? Those hard braces are not understood in their literal way. They're kind of grouping the characters contained in them in some kind of special way that we'll learn about in just a minute, okay? All right, so let's talk about special characters. As I said, in some cases, escaping literal characters is going to signify something else. In other words, escaping ordinary characters, A, Z, that kind of thing, taking them from their literal sense into their meta sense is going to communicate something else. So what's a way that we can think about that? Or what kinds of examples do I have for you? A complete listing is going to be in the documentation for regex. So just do !regex and you're going to get kind of a full listing, which is much more than you ever really cared about, okay? I would say the most important ones are /in. /in is going to signify a line break, like a new line, okay? And /t is going to specify a tab. So if you open up a data set, for example, somebody sends you a CSV file, and you open it up and you realize that there's not commas actually separating the columns, it's actually /t's. And you're like, what the heck is going on? Those /t's are actually tabs. It's actually a TSV, tab separated values file that somebody has saved as a CSV file. And now you've got to kind of go back and convert it, okay? Usually the reason why they'll do tabs is that if you open it in a lot of word processors, the word processor is going to kind of give you some kind of not fixed width for tabs, right? So it's going to kind of like align the characters and make it look kind of nice. So a lot of folks will kind of save it like that, not really thinking about, hey, this is actually a really weird thing to do, okay? Now, there's the difference between a character, like a string, a sequence of characters or a string, and the way that string is printed, okay? To see the difference, you would need to print that string, okay? But you don't do it with the print function, which is a little weird or ironic. You actually do it with either the cat function or the writelines function. In Hadley's book, he uses writelines to do this. I'm going to use cat. It's going to be the same thing, okay? So cat A/NB is actually going to print that to the screen, okay? A followed by a B. Now, that looks a little strange, but that's what you get, right? That /in is playing the role of make a new line, right? So the new line is here getting interpreted, and it's interpreted when it's printed. Okay, the /t, same way. It looks like there's a space there. There's actually a tab there, okay? Now, you can actually check if this is the case by actually typing in str_detect, quote, a new line B, and then saying if it actually sees A/NB, okay? So here you see, oh, that's what it's actually matching, okay? So those are in fact the same string, even though it looks like they're quite different, okay? Now, let's talk about character classes, going back to this like hard brace stuff. What's going on with character classes in the hard brace? So a character class is a single character regular expression. So this is maybe the most important thing you need to know right off the bat, okay? A character class is going to signify a single character, okay? But it's going to be, that single character is going to be somewhere intermediate between a very specific character, F, and the wildcard dot, okay? If the wildcard matches everything and F only matches F, it helps to have kind of like an intermediate character that could match, something between absolutely everything and only F, right? Like maybe you want to match A, B, C, but not any of the other letters. Like how would you specify that? So this is the first kind of real regular expression that we're getting, okay? Character classes are demarcated with hard brackets. So the basic idea is you're going to list off all of the possible characters between those hard brackets, okay? So there's a very common word that's used here for this illustration, which is gray, okay? Gray could be spelled with an A, G-R-A-Y, or E with G-R-E-Y, and both of those are generally accepted spellings of the word gray, okay? But how would you match those if you're actually just looking through a corpus, like a body of text, and you want to say, hey, do you see gray in there anywhere, okay? So Gray Street, str detect gr hard brace A or E followed by a Y, okay? So the hard braces is saying match a single character. Character classes always match a single character. And the single character that it will match here is either A or E. Those are the only ones that are allowed. So if I did Gray Street, it would match that too. If I did GRAE Street, now it doesn't match because the hard braces, the character classes, only match a single character, okay? So they're kind of listing out alternatives, but only for a single character. Now, it would be really, really tedious if you only wanted to match, like if you had to actually literally list off and enumerate each of the characters that you want to match in the character string, in the character class. So there is some functionality within the character class to specify ranges, okay? So the dash is how you're going to do this. So if I want to say I have 3 kids and I want to pull out the number there, I could say str extract hard brace 0-9, and it knows the order of the characters. Computers have kind of lower level order of characters, including letters and so on. And so the 0-9 is going to match any of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, makes sense? Pretty simple. Now, this gets us into a really weird world about meta-ness, okay? If you go back to the previous listing that I had of meta characters, you'll notice that the dash is not a meta character, okay? So, strangely enough, this notion of a meta character is going to actually change inside of a character class, okay? So, things that are normally meta or normally literal inside of character classes can actually change their meaning, okay? Now, this is not something that should, really confuse you. So if that feels a little weird, don't worry about it too much. Just think to yourself, oh, like inside of a character class, some things play a little differently, and the dash is one of those, okay? Because the dash is going to be playing the role for a range, okay? So the dash is the first one that we met. I could do 0-9. I could do little a dash little z, all the lowercase characters, big A dash big Z, all the uppercase characters, and so on, okay? Now, here's a setting. When I put the period in the character class, now it toggles into literal meaning, i.e. non-meta, right? And that's because within the character class, meta rules are different than outside the character class, okay? And inside of a character class, period does not play the role of a wild character. If it kind of did, that would be useless because the overall character class is a single character. So if I put period in there, it's like saying like match anything. I mean, if it were actually meta, okay? But it's not. So here's another example of something that is actually kind of useful. So if you put a caret, that is to say, shift 6, right after the opening bracket, that specifies anything but these for the character class. So instead of being in the character class and listing off the characters you want, you would be in the character class and list off the characters that you don't want, okay? And you don't want to match those characters. So hat, het, hit, hot, hut, it could be matched using this simple regular expression, okay? Again, look at the character class. The character class is everything in the hard braces, and it starts with this caret. That says match any letter there except for A, I, and U, and there's a whole lot of characters there, okay? So it's going to match any of those, all right? Now, there are some ranges of character classes that are just so common to use when you're actually doing regular expression stuff, that it's actually helpful to have a shorthand for those character classes. For example, if you want to match a number, sorry, I shouldn't say a number, because a number could be a sequence of digits, right? Glyphs. So if you wanted to match a single digit, 0, 1, 2, 3, 4, 5, 7, 8, 9, okay? You could use the character class right here on the right. So this character class, hard brace 0-9 hard brace, okay? However, that's so common that you want to actually express that it's actually easier to have a shorthand symbol for that. And the shorthand symbol is /D, okay? So if you escape the D character, which is literal usually, if you escape it, now it's referring to a digit, okay? 0 through 9. If you use capital D, now that means it's not that, okay? Match any character but a digit, okay? And the same thing goes for these other two, okay? /W is super duper important. You'll find yourself using this all the time. It says match a word character, okay? What is a word character? A word character you should think of pretty much as any character that you would make a variable name out of, okay? So all the lowercase and uppercase letters, all the digits, and underscores, okay? What is it not? Maybe it's helpful to think of what a word character is not. A word character is not a space, right? It's not a tab. It's not a new line, right? Things like that. It's not a quote, right? So when you're trying to match words, usually you'll try to match words with word characters. There's some exceptions to that. You may say to yourself, well, no, I don't want digits to be in there or something like that. But it's a basic rule, a word character is going to be digits or letters or an underscore, okay? Again, think kind of anything that you could match with a variable name, okay? The capital W, less often used, not a word character, but that's just fine. /s plays the role of white space. So it will match a single character that is kind of classified as white space, okay? Now, white space here doesn't just mean literally a space on your computer. It could also mean anything that kind of takes up space but breaks the usual flow of text, okay? So what are we thinking? We're thinking a space that I just underlined right there. It's hard to see, unfortunately, but that's a single character that is a space. /n, new line, /t, tab, /r, carriage return. I've not talked about carriage returns. That's what happens when you escape the R, okay? The R character, which is usually literal, okay? When it goes meta on you, when you do /r, now it's a carriage return. What is that? If you think back to kind of the days of typewriters, okay? There's a little thing on the typewriter that when you push this little lever, the whole carriage of that typewriter kind of goes back, and it makes that sound like jing, you know, and then you can start typing again, okay? In other words, as you're typing, the whole thing is like moving over, and actually it moves back this way, okay? So you can start a new line, okay? Interestingly, when it did that, it did not actually rotate the little canister thing. I forget what the term is. The drum. It didn't rotate the drum, so it doesn't move you down a line. It just literally moves you back to the far left side of the page where you're already typing. And it kind of erases, in the computer sense, it erases everything that's currently there. So that's what a carriage return is actually going to do. It's going to move you back to the line, like it's going to wipe that line, and you can start typing over it. So this is useful for things like progress bars, okay? Where you have like dash, 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 dash. It's not actually adding to that line. It's putting that line, and then it's wiping the whole line, and it's putting two of them, right? Wipes the whole line, 1, 2, 3, and so on, okay? That's a carriage return, /r. You don't see it very often, but it is useful to know that that's what's actually going on, okay? Here's an example of doing stuff with this. So here's 2 lines. The office phone number is 254-710-6102, blah, 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 okay? Now, I want to use regular expressions. I want to use these quick character classes to do some nice matching here, okay? So I could say, take the lines and extract every instance of the regular expression, a digit followed by a digit. Maybe I'll underline these to make it very clear. Digit followed by a digit followed by a digit, dash, which is literal, not meta, because it's not inside of a character class, digit, 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 dash, digit, 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 okay? Now, those are phone numbers, right? So it will extract those phone numbers, and there you can see that it actually did, okay? So it pulled out every instance of a phone number in those 2 strings. Now, there's a question, which is there a better way to do that? I mean, that seems pretty verbose. Surely there's a better way that we can express the idea that is match 3 digits followed by a dash, followed by 3 digits, followed by a dash, followed by 4 digits, okay? And in fact, there is, and this brings us to regex quantifiers. This is where you're gonna get most of your meta characters, okay? So on the left-hand side, I'm gonna show you the meta character that I want to match. And on the right-hand side, I'm gonna say str view all, and I'm gonna give you the regular expression, and you can see here what it matches, okay? Let's talk about the first one first, and then I think that you'll kind of get the hang of this, okay? The first one is the question mark. And the question mark says, match the preceding character either 0 times or 1 time, okay? In other words, the question mark is kind of like, could it be there? Like, it could be there or it could not be there, okay? So match an A 0 or 1 times. In other words, it's an optional thing, okay? So let's see the matches that result from B followed by an A, which may or may not be there, okay? May or may not be there. So it matches this B because it's a B, and there's not an A afterwards. The A that's not afterwards, that's fine, right? Here's a B by itself, okay? Another match. Here's a match, BA, okay? It's a B followed by an A. That's a whole match for this regular expression. That's a single match, right? This B is a single match. The colors are very important here, the yellow and blue, to distinguish what are the matches, okay? Notice that BAA is not a match, but that sub-expression BA is because it matches exactly 1A, okay? All right, hopefully this is clear to you. If it's not, just review what I just said, and hopefully that will be clear. If it's not, obviously come and talk to me, okay? The asterisk is the next one. The asterisk says match any number of them, okay? 0 or more, okay? If there are any number of A's, just match all of those. So I have here matching a B. I match BA, I match BAA, match BAAA, and those are single matches, okay? And then I also match, of course, the blue B's that you see there. Now, what if I want to make sure that there's at least one match of that kind of thing there? That's where the plus sign comes in, okay? So now already in this one slide, we have 3 meta characters coming at you. Question mark, that means 0, 1. Asterisk means any number of them, and plus means at least one or more, okay? And that's why you would match BA, BAA, BAAA, okay? That's exactly how this works. I think that's hopefully pretty clear, okay? Now, you're gonna get 3 more, and these 3 more are going to communicate like kind of numbers of matches, okay? So if you say a curly brace in, first of all, here we go. Now we know both the meaning of the curly braces. The curly braces are quantifiers that are quantifiers in this kind of exact number, or I'll go ahead and show you these, or ranges sense, okay? So again, let's just kind of focus here for a minute. That says match exactly in A's, okay? So if I say match BA2 like that, it's going to match this BA and this BAA. Sorry, this BAA and BAA. There's got to be 2 A's there, right? Even though I don't actually have to type out both those 2's, okay? Now, you can use a comma inside of the curly braces to indicate a range, okay? And maybe the best place to start here is actually the bottom case. Maybe it's like this case, which says match somewhere between N and M of those characters, okay? So if I say BA12, it's going to match this BA, this BAA, and this BAA, okay? But not the full BAAA, BAAA, 3 of them, 3 A's, okay? It's not gonna match that because that's outside the range, okay? Now it's easy to understand kind of what's going on here. In that purple case, what's happening is, or magenta case, if you leave off one of the numbers, okay, you use the comma, but you leave off one of the bounds, it's just going to say like go all the way on that bound. So if you say in comma, that says in or more, right? If you said comma M, it's saying anything less than or equal to M, okay? So kind of bounding on that side, okay? That's how those regular expression quantifiers work. So a lot of the meta characters are actually regular expression quantifiers, okay? That's a good way to think about it, okay? Now, let's see if we can use those quantifiers to simplify the phone number. And the answer obviously is yes, okay? And here's how we would do this. So we want to match a digit exactly 3 times, followed by a dash, followed by a digit exactly 3 times, followed by a dash, followed by a digit, followed by exactly 4 times, right? Exactly 4 digits. That makes perfect sense. It's a very simple way to express a phone number. That's probably the way that you think about a phone number, is something like that. Now, it's still kind of complicated, right? Because it could include like parentheses, or maybe they don't have parentheses, maybe they don't have the dashes, maybe the dashes are spaces or something like that, okay? So maybe in that setting, we would actually want to put in a character class, right? There could be a dash or it could be a space, depending on how the person actually inputs it, okay? So these regular expressions themselves can actually get quite complicated. Let's look at an example with email scraping, okay? Here is the web page of the Department of Statistical Science at Baylor, and all web pages, many web pages are going to list emails. Some don't these days. Some people try to obfuscate them by changing what they look like, which in many cases is just kind of futile, because people are going to write regular expressions that will match those obfuscations as well. But in any event, let's look at our page. So the email addresses are listed there. If you looked at the source HTML of the page, which we talked about in terms of our Markdown, and like the whole purpose of Markdown and marking up into HTML, you'll see that there are those web pages embedded in the source of the page. Now, that's not very surprising. What we want to do is we want to write a regular expression that's actually going to go in and pull all of those out. Okay, so let's see how this example kind of continues. So I'm going to use the readlines function to download the HTML lines of that web page, okay? So now faculty page is just going to be a character vector of length 86. That's this right here. And the characters are actually HTML's code. So if you look at it, it looks kind of complicated, right? Like all of this kind of HTML code, which may not be very familiar to you, okay? However, embedded in that, we know that there are those web pages. So we could say str extract all, give a simple little regular expression that signifies I want to pull out everything that looks like something at baylor.edu. And then I'm going to simplify it, and boom, I have all of the email addresses of all of the faculty listed at those pages. So you could apply a similar kind of thing to, lots of different university web pages or different departments and so on. You may need to change the regular expression a bit and that kind of thing. But the basic idea works to go out and aggregate a whole bunch of email addresses. And this is essentially how spamming works, right? You'll have a database of just tons of email addresses, and then you'll send out emails to all of them, okay? So you use your powers for good. Groups. This is the next milestone in our discussion of regular expressions, and it's kind of nearing the last. Groups are new metacharacters. They're the parentheses, and they are going to signify collections of characters to act as single units, okay? Previously, we had quantifiers, but the quantifiers plus the time symbol and so on, all of those only work on the preceding character, one character, okay? Unless you group things together. So if you group things together with parentheses, it's going to say, hey, apply it to the entire group, okay? Now, you can't put groups in character classes. And the reason why is that groups are intended to associate several characters together. But a character class always means exactly one character. So it wouldn't make any sense to be able to put a group inside of a character class, okay? Let's look at an example. Hopefully this will make it clear. I want to look at this vector here, and I want to match this, okay? L followed by EA, and that EA could either be fully present as E and A, or it could be fully absent as nothing, right? That's followed by a D. That's the way that this should be understood. So LD matches because there's no EA, and LEAD matches because there's the full EA, right? But neither of the others match, okay? This would be a situation, if I had replaced the grouping and the question mark by heart braces, just the middle things would match, right? So this is kind of like, in some sense, the opposite, but just for this case and just with the question mark and so on. That's just a very special instance. The grouping generally, as I said before, is going to be understood to associate several characters together to almost operate like one character. All right, how about this example? This example removes the grouping. Notice that the question mark is only going to apply to the A, right? So LD does not match. This does not match. LED, that does match because the E is not followed by an A. That's good to go. The LAD doesn't match because it doesn't have the E, and the LEAD does match because it has that A after the E, okay? So hopefully going through these examples, you can kind of see exactly how these things work, okay? Grouping is very closely associated with another concept called alternation. And alternation is essentially the idea of a character class, but for several characters at once. In what sense? Like this. A character class allows you to express alternatives for a single character, right? Alternation is going to allow you to express alternatives for collections of characters. And as I said, these are almost always associated in practice with parentheses. They don't have to be, but they almost always are. Now, you're going to meet a new meta character here, and the new meta character is the pipe. And the pipe, just like an R, means or, okay? It's going to signify alternation, okay? So let's look at an example. Here's this string, I feel happy today, and I have alternative sequences of characters. So it could either match SAD as a full sequence, or it could match HAPPY as a full sequence, or ANGRY as a full sequence, or SURPRISED as a full sequence, okay? Not partially though. So it would have to match one of those, okay? One of those sequences of characters. And that's the sense in which it's kind of like character classes, but for many characters simultaneously, okay? So sad, happy, angry, surprised, okay? Now, let's use this grouping along with glue and some other things to kind of make a email scraper that is more than just something at something.com. Let's try to actually capture situations where somebody has tried to obfuscate their email with something like this. foo@bar.info. You've probably seen this kind of thing, okay? How would you write a regular expression that matches all of those cases? Well, let's first write a regular expression that generally communicates the idea of like the @ symbol, okay? So this says 0 or more spaces followed by the @ symbol, followed by 0 or more spaces. Or maybe the person says 0 more spaces followed by AT followed by 0 more spaces, okay? That's an alternative, right? It could be either of those, and I'm going to group it together, okay? And I'm going to do this for each of them. So the dot is the same way. They could write DOT, or they could put the period symbol. Doesn't matter to me. The domains, that is the thing that comes after the dot whatever, com, edu, and so on. There's lots of these, so we're just having a kind of basic example of what this would look like. And we're going to group together with alternatives, okay? Now, I'm going to create a regular expression using glue, okay? So you can see already how like this world is expanding as I take these small tools and I build them I kind of assemble them in a way to build something that's big and much more complicated that I would certainly not have wanted to type out by myself, okay? So what does this look like? Well, it says my email, or the email addresses that I want to match, look like some number of word characters, one or more word characters, followed by a regular expression that matches an at, right? That's this, followed by some other number of word characters, followed by some regular expression that matches dot, followed by regular expression that matches domains, okay? And then the whole regular expression itself gets real big and looks complicated, right? And it's because I kind of typed it in pieces and then I assembled those pieces. Each of the pieces were actually very, very easy to understand. But when I actually assemble it all together, now it's kind of like you got to look at it closely and it looks kind of complicated on you, okay? It's not that bad. You just have to understand it analytically by pieces, okay? Break it up. So glue is very useful for this. So what I'll do is I'll take the emails, I'll move them all to lowercase, and then I'll use str extract all with my regular expression, okay? And I have all of the email addresses, even the ones that folks tried to intend to obfuscate on the webpage, okay? So it's actually a very, very easy thing to get to circumvent that, okay? And this is what all the matches would look like. Notice here that I've also used the replace functions to actually go in and not only extract them, but then convert them to a normalized form of what an email address usually looks like, right? That you would actually need to type in an email client to actually create that email address, okay? All right, two more concepts. So back referencing. Back referencing is, or maybe I should say three more concepts. Back referencing is referencing matches that have been previously made, okay? So here's an example. I think probably the best example that I know of this is write a regular expression that matches repeated words in an essay, right? So like when you're writing an essay, it's very common to make a little mistake and you'll type the same word 2 times, the. And of course you didn't actually type the. What you did was you typed the once and then you wrote some other stuff and then the again, and you kind of edited it. But when you edited it, you didn't notice that you actually put 2 these back to back, okay? How would you communicate something like that in a regular expression? That's challenging, right? Because you don't know what the word is that's going to be repeated, right? You know that there's going to be some sequence of word characters, but then you're going to you want to match the exact same thing again, okay? To do this, you need to do something called back referencing. Back referencing is going to use grouping. So look at this regular expression, or the sentence first. I kicked the ball, okay? The regular expression says match 1 or more word characters followed by /1, okay? And then in R it becomes /1, okay? That /1 is going to signify the first group that was matched, okay? So slashes followed by numbers are back references, and they're going to refer to groups that were previously matched, okay? So here it extracts the, okay? That's the thing that's duplicated. In some cases, you can actually use replacement functions. I've had kind of moderate success with this in R. In general, certainly this works in regular expressions, but for some reason in R, this doesn't always work as cleanly as you might think. So is there a way to write a regular expression that would actually fix that? And the answer is yes, just use the back reference in the replacement part. And that works, as I said, so-so. Your success will probably be something like 50% as you do this, okay? So you can do this here it works, in other places it may not work as well, okay? There's another little example here. I'm gonna skip this just for time. Now, lookarounds. A lookaround is a kind of regular expression that's going to allow you to match it's going to allow you to match a regular expression that has something around it in a way, okay? So as an example, let's say that you are scraping, like you're looking at textual data and the textual data is letters, okay? And you know there's always a salutation, dear so-and-so, comma, okay? You don't know what the regular expression is on the inside, okay? Like the name of the person, okay? But you do know that it's gonna start with dear so-and-so something, but you don't want to match the so-and-so. You don't want to match the dear. You just want the name of the person, right? How would you say, I want you to match a sequence of characters that follows dear, right? How would you do that? And that's what lookarounds are for, okay? Lookarounds, they're always signified. I'll kind of go ahead and list all of these out here. Lookarounds always look like this. They're always groups, and they always start with question marks, okay? They always start with question marks. So parentheses followed by a question mark, followed by either equals or less than or equals. Okay, this is the way you should think about this. So let's look at the first one. So match regex1 followed by regex2. So here is regex1 followed by here is regex2. Okay, so I want you to match whatever this regular expression is, and if you're reading it, coming after that would be this one. Okay, or like in the salutation case, I want you to find dear space, but I want you to actually extract whatever the name is. Okay, that's how that works. Okay, now let's kind of see an example of this. So salutation, dear David Kale. Okay, str extract all. Now this says dot plus 2 meta characters, right? So this could say any character, any number of times, at least once, right? At least once, followed by a comma, but match those characters. And it pulls out dear David Kale, no comma. Okay, now you could do this the other way around. You could match everything following dear space like this. So group question mark less than or equal to dear space followed by any number of characters. Okay. Now here the problem is that, of course, that you match this, and here the problem is that you match that. So you could actually combine these two together to match all just the characters in the middle, and it would look like this. Okay. Okay. The last topic we're going to talk about is anchors and word boundaries, and these have to do with matching kind of like the beginning of a line or the beginning of a word. Okay. Line anchors. There are 2 line anchors, which are the caret and the $sign. The caret is a meta character, and it signifies match the beginning of the line. The $sign is a meta character, and it says match the end of the line. Okay, so if I say A, B, C, D, E, str detect B, it says, hey, it's there. If I put a caret B, that may look from previously, like the character class stuff, it may look like not B, but that's actually not what it's signifying. It's signifying match a B that immediately follows the beginning of the line. In other words, B has to start the line. Okay, so if you find that, you're kind of good to go. I say beginning of the string, I really mean the beginning of the line. Okay, the same thing goes for a D here. So A, B, C, D, E, it matches the D, okay, but it doesn't match the D followed by the $sign, and that's not because there's no $sign in it, right? It doesn't find the $sign because D is not the last character of that line. Okay, so D matches not the end of a string, the end of a line. Okay, I guess you can think about it. Okay, so on to word boundaries. Word boundaries are just like anchors, but instead of matching the beginning or end of the line, they match the beginning or end of a word. Okay, so essentially like where white space changes into word character. That's word boundary. Okay, so I'll list these examples here. This is already getting longer than I had anticipated, and this is a kind of deeper cut. So it's not too important that we really understand or that we go through these examples. I don't think it's too challenging. It's just important to see that these exist if you want to match the beginning or end of a word. Okay. Now, this is kind of more extensive use of this. So this is the end of this slide deck. Hopefully you have understood string processing and regular expression. In general, the more experience that we can get with something, the better. So when it comes to text processing especially, I think it's important that you actually get your hands dirty and you actually start manipulating some textual data, okay? So we'll call it a video from there. If you have any questions, please reach out to me.